Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Greetings everyone. Today we're diving into the Temporal Fusion Transformer, TFT, for time series forecasting. Can you give us a brief overview of the motivation behind developing this model?
The Temporal Fusion Transformer, TFT, is a neural network model specifically designed for time series forecasting. Traditional time series models often struggle to capture complex patterns and relationships in data, especially when dealing with multiple time series. TFT addresses this limitation by leveraging a global modeling approach, which considers the relationships between different time series, rather than modeling each series independently. This allows TFT to capture intricate patterns and dependencies that would otherwise be missed by local models.
Thank you for that insightful introduction. Can you elaborate on the key components of the TFT architecture? How do they contribute to the model's effectiveness in time series forecasting?
The Temporal Fusion Transformer, TFT, model is a powerful tool for time series forecasting. It is a global model, meaning that it models the relationships between different time series, rather than modeling each time series independently. This allows TFT to capture complex patterns and relationships that would be difficult to model with a local model. The main components of the TFT architecture are encoder. The encoder is responsible for converting the input time series data into a fixed-length restudy. This restudy is then used by the decoder to make predictions. Decoder. The decoder is responsible for generating the output time series data. It uses the restudy generated by the encoder to predict the future values of the time series. Attention mechanism. The attention mechanism allows the decoder to focus on the most important parts of the input time series data when making predictions. This helps to improve the accuracy of the model. These components work together to make TFT a powerful and efficient model for time series forecasting. The encoder and decoder are both based on the transformer architecture, which is a type of neural network that is well suited for processing sequential data. The attention mechanism helps to improve the accuracy of the model by allowing it to focus on the most important parts of the input data. As a result of these components, TFT can achieve state-of-the-art results on a variety of time series forecasting tasks. It is a powerful and efficient model that is easy to use and interpret.
Thank you for providing those details about the TFT architecture. Can you further explain how the model's interpretability feature enables users to gain insights into the time series data?
TFT, or Temporal Fusion Transformer, provides a unique feature called model interpretability through the use of self-attention mechanisms. Self-attention mechanisms allow the model to focus on various sections of the same input sequence while making predictions. The model highlights the relative significance of specific attributes or time steps in the forecasting process by paying attention to them. This aids in comprehending the fundamental variables driving the forecasts and extracting insights from the data.
Thank you for explaining the interpretability aspect of the TFT model. Can you provide specific examples of how this interpretability helps users understand the underlying patterns and relationships in time series data?
Sure. Here are some specific examples of how TFT's interpretability helps users understand the underlying patterns and relationships in time series data. Highlighting important features. TFT's self-attention mechanisms can highlight the specific features or time steps that are most important for making predictions. This can help users understand which factors are driving the forecasts and gain insights into the data. For example, a TFT model might identify that a particular product category is more likely to sell well during certain times of the year, or that a certain type of weather event is likely to lead to an increase in sales. Identifying relationships between time series. TFT's global modeling capabilities can help users identify relationships between different time series. This can be useful for understanding how changes in one time series might affect another. For example, a TFT model might identify that sales of a particular product are correlated with sales of a complementary product, or that sales of a particular product are affected by the weather in a particular region. Explaining model predictions. TFT's interpretability features can help users understand why the model is making certain predictions. This can be useful for debugging the model and for gaining confidence in its predictions. For example, a TFT model might provide an explanation for why it predicts that sales of a particular product will increase in the next month, based on the factors that it has identified as being important.
Thank you for providing those clear examples. Can you further explain how TFT's interpretability aids in debugging the model and enhancing its overall reliability?
The interpretability of TFT helps in debugging the model and improving its overall robustness. By providing explanations for the predictions, TFT allows users to understand the model's decision-making process and identify potential errors or biases. This can help in identifying and fixing issues that may affect the model's performance, leading to a more robust and reliable model.
Thank you for clarifying that. Can you provide a specific example of how TFT's interpretability helped identify and fix an error or bias in the model's predictions?
The Temporal Fusion Transformer, TFT, model is a global time series forecasting model that can capture complex patterns and relationships between multiple time series. One of the main benefits of using TFT for time series forecasting is its ability to model the joint distribution of multiple time series, which allows it to capture complex patterns and relationships that would be difficult to model with a local model that only considers a single time series. Additionally, TFT is a neural network model, which means that it can be trained on large datasets and can learn complex relationships between time series.
Thank you all for joining us today. We've covered a lot of ground in our discussion of the Temporal Fusion Transformer, and I hope you found it informative. As we've seen, the TFT is a powerful tool for time series forecasting. It addresses the limitations of traditional models by leveraging a global modeling approach that captures relationships between multiple time series. This makes it well suited for a wide variety of applications, such as predicting stock prices, forecasting demand, and monitoring system health. In addition to its accuracy, the TFT is also interpretable, which means that users can gain insights into the time series data by highlighting important features, identifying relationships between time series, and explaining model predictions. This feature makes the TFT a valuable tool for researchers and practitioners alike. I encourage you to learn more about the TFT and explore its potential for your own work. The resources provided today are a great place to start. Thank you again for joining us.